Scientists have found concrete evidence that there's a vast ocean beneath the Earth's surface. The idea of an underwater world has driven plenty of science fiction, but now one group of researchers says it's not too far from science fact. They discovered an area inside the Earth's surface that's believed to hold many times more water than the rest of the Earth's oceans combined. If it turns out to be accurate, our models of how water appeared on Earth might need serious revisions. It would also be a turning point in our understanding of the interior of the Earth. But the intriguing question is how they found evidence about this undiscovered ocean. What led them to propose such a radical idea? The answer is a rare piece of diamond discovered earlier in 2022. This diamond was found in a diamond mine in Botswana, Africa. When it was analyzed, researchers found that it originated 660 kilometers or 410 miles below the Earth's surface. The depth at which the diamond was formed is at the deepest part of the transition zone, the boundary layer separating the Earth's upper mantle from the lower mantle. Minerals found in areas lower in the transition zone, closer to the Earth's core, are denser and less likely to move like the tectonic plates closer to the Earth's surface. While analyzing the contents of this stone, the researchers noticed something unusual. They found that this piece of diamond contained ringwoodite with hydrous phases, which means it is rich in water, and the transition zone is a wet environment. Most of the Earth's surface is covered with oceans, yet considering the thousands of kilometers between the surface and the planet's core, they're barely a puddle. Even at its deepest point, the ocean is just shy of 11 kilometers or 7 miles thick, from the wave tops to the floor. But Earth's crust is cracked and fragmented with separate tectonic plates that grind together and slip under each other's edges. Water seeps deeper into the planet at these subduction zones, reaching as far as the lower mantle. Over time, it makes its way back to the surface via volcanic activity. This cycle is known as the deep water cycle, separate from the water cycle active at the surface. The knowledge of the deep water cycle and the quantity of water present down there is essential to understand the geological activity of our planet. For example, the presence of water can influence the explosiveness of a volcanic eruption and play a critical role in seismic activity. Since we cannot go down there, we have to wait for the evidence of water to come to us, as it does in the form of diamonds that form crystal cages in extreme heat and pressure. The team used micro-Raman spectroscopy and X-ray diffraction to probe the diamond. They found the assemblage of ringwoodite, ferropericlase, and enstatite. Now, this is important because, at the high pressures at the transition zone, ringwoodite decomposes into ferropericlase, as well as another mineral called bridgmanite. At lower pressures closer to the surface, bridgmanite becomes enstatite. Their presence in the diamond tells a story of a journey, indicating the stone formed at depth before making its way up to the crust. The hydrous nature of ringwoodite and bridgmanite points to the facts that the region is quite slushy, and there could be more water down there than all of Earth's oceans combined. And this finding could impact another groundbreaking discovery this year. Earlier in 2022, researchers found something alarming regarding the Earth's core. They found that the core is cooling faster than we previously thought. As a result, it will solidify in the future, turning our planet into a barren world like Mars and Mercury. The evidence of this came from the same mineral found in the diamond, bridgmanite, since it lies precisely at the boundary between Earth's outer iron-nickel core and the molten fluid lower mantle above it. Its ability to conduct heat is a crucial factor on which the rate of heat seeping through the core and out into the mantle depends. The more the conductivity of the bridgmanite, the faster the heat transfer and the quicker the interior will cool. So researchers irradiated a single crystal of bridgmanite with pulsed lasers to determine its conductivity. Simultaneously, they increased the temperature to 2,440 Kelvin and pressure to 80 gigapascals to mimic the conditions prevalent in the lower mantle. And the results were surprising. It was found that the thermal conductivity of bridgmanite is about 1.5 times higher than previously assumed. Besides that, when bridgmanite cools down, it transforms into another mineral called postperovskite. Postperovskite is even more thermally conductive than bridgmanite. This indicates that it would further increase the rate of heat loss from the core into the mantle. All these observations suggest that Earth, like the other rocky planets in our solar system, is cooling and becoming inactive much faster than expected. But now geologists will need to consider the discovery of the hydrous minerals in this diamond that form deep below the surface. If there's so much water down there, how is it impacting the rest of the internal environment? In addition, previous research has found that Earth is sucking down way more water than we had previously thought, and this could finally give us an answer as to where it's all going. If you enjoyed this video, subscribe to our channel for more.